So this is the 50th session on relative velocity. In this also I'll take up a equation on a relative velocity problem for Riverman problem, in which the flow velocity is still uniform, same everywhere, but we are asked to find the polar equation of trajectory of the swimmer. Okay, so first I'll write down the question. A straight river of width L flows towards east at a constant speed nu with respect to ground, which flows towards east at a constant speed nu with respect to ground, where n is a positive number, okay, positive real number. S is a swimmer whose swimming speed with respect to river is u. A is the point on south bank and the starting point of the swimmer, and is the starting point of the swimmer okay. O is a point on the north bank. Just opposite to point O. O is a point on the north bank just opposite to point A. Opposite to point A. The swimmer swims across the river such that his heading is always towards O. Fine. Find the polar equation of trajectory of the swimmer with point O as the pole, and line along positive eastward direction as the reference line. Direction as the reference line. Fine, all right. So this is a bit okay. So I'll draw the diagram, okay? This is the top view of the situation, top view. This is the top view of the river of width L, flowing towards east at a constant speed nu. A is the starting point of the swimmer. O is a point on the north bank just opposite to point A on the south bank. Swimmer starts from here. Again, instead of object under consideration is swimmer, denoted by S. Intermediate frame we have the river frame, M frame, denoted by R, say. And instead of F frame we have ground frame, we have G. Okay. A swimmer starts from here. This is the pole. This is the reference line from where angle is being measured. Swimmer is initially here. Now we write down the vector equation. VSG is equal to VSR plus VRG. Now VRG is known NU towards eastward direction. VSR magnitude is known, its magnitude is U. And the heading of swimmer is towards O. Heading of swimmer means direction of vector VSR. VSR is always directed towards point O. Okay, and its magnitude is constant U. And VSG denotes the velocity of swimmer with respect to ground at some arbitrary instant after it begins to swim across the river. Suppose the swimmer is here at time 0, this is time 0. At time t, swimmer comes somewhere here. This is the swimmer at time t. I'll just write it here. This is the swimmer at time t. Alright. This is the swimmer at time t. Suppose distance of swimmer at time t from O is R. This angle is theta. Now VSR has a constant magnitude U and heading of swimmer is towards point O. That is VSR is directed towards point O. Heading means direction of VSR. So this is the direction of VSR, it is U towards point O. And VRG is NU towards the eastward direction, NU. The velocity of swimmer with respect to ground is the vector sum of these two. Okay. So now I'll define two unit vectors. One unit vector ER hat, other unit vector this one E theta hat. Alright. So now we know, as we have discussed problems on cylindrical coordinate system. To know the details of cylindrical coordinate system, you can go to the sixth video on particle kinematics. There you will get the details. Around that 1-2 video, this way or that way, you will get all the details of coordinate system, cylindrical coordinate system. Okay. So VR, it is the radial component of VSG. Radial component of what? VSG. That is the radial component of VSG, VR. That is how much? dr by dt. That is the component of VSG along ER. This is radial component of VSG meaning what? Component of VSG along ER hat. And that is known as VSG dot ER hat by the definition of component. Component of vector A along given direction is A cos alpha. That is just A dot n hat. N hat is the unit vector along that direction along which component is to be found out. ER hat is VSG dot ER hat. Now VSG is what? VSR plus VRG. VSR plus VRG dot ER hat. Now VSR is what? U times minus ER. Minus U times ER hat. And what is VRG? VRG is this way. This is theta. This is right angle. By geometry, this will also be theta. So VRG will return as what? NU times, this is 90 degree minus theta. The VRG will return as what? I'll write it simply. Okay, fine. So plus VRG, yes. VRG is VRG dot ER hat. So if I get this dot product, minus U into ER dot ER hat plus VRG dot ER hat. ER dot ER hat is 1. Minus U plus. Now what about VRG dot ER? VRG dot ER becomes magnitude of VRG, which is simply NU, into magnitude of ER, which is simply 1, into cos of angle between VRG and ER. VRG cos of angle between VRG and ER. Okay. VRG. Now VRG is the velocity of river with respect to ground. So angle between VRG and ER is 90 minus theta. So this becomes cos of 90 minus theta. Cos 90 minus theta is simply sin theta. Minus u plus nu sin theta. This is equal to VR, radial speed. Okay, fine. So one equation what we have obtained, dr by dt is just equal to nu sin theta minus u. Nu sin theta minus u, that is dr by dt. Fine, alright. So dr by dt is nu sin theta minus u. This is the first equation. Alright, fine. So I'll write down the second equation. Radial speed of swimmer, v theta. Radial speed of swimmer. Radial speed of swimmer. That becomes how much? That is simply the component of Vsg along E theta. That is just equal to Vsg dot E theta. Also we know that v theta is what? R d theta by dt. From the theory of cylindrical coordinate system, you go to the 6th or 7th video of particles kinematics video, you get the details. So R d theta by dt, Vsg dot E theta. Vsg will be written as what? Vsg is vectors of these two. So Vsr plus Vrg dot what? E theta hat. Alright. So this is the bit, okay? So now R d theta by dt, this becomes Vsr dot E theta, Vsr dot E theta plus Vrg dot E theta. Now Vsr dot E theta becomes 0 because Vsr is towards opposite to ER and E theta is right angle to ER. Dot product of two perpendicular vectors is 0, this goes away. Vrg dot E theta. Now Vrg is this direction, E theta is this direction, angle is theta. So this will be how much? Nu into 1 into cos theta. Okay. So R d theta by dt is just equal to Nu into cos theta. And dr by dt is just equal to what? Dr by dt is equal to what? U times n sin theta minus 1. Okay. From these two equations you have to find the relation between R and theta. I'll drop this one, okay. So from this equation it follows that dt is what? R d theta by Nu cos theta. And from this equation it follows that dt is what? Dr by U into n sin theta minus 1. These two dt's are same, so these two should also be same. R d theta by Nu cos theta dr by U times n sin theta minus 1. U and U will go away. Okay. Then what do you get? We separate the variables. Dr n dr by r is equal to n sin theta minus 1 by cos theta into d theta. Alright, fine. So now what I do, I integrate this equation. N sin by cos becomes tan. And 1 by cos theta becomes sec theta into d theta. Now what is the initial value of r? Initial value was here. R is equal to L. And corresponding theta is what? 0. And arbitrary instant swimmer is here, then R is equal to R. And theta becomes theta. Now this one integrated, this will, and inserting limits, we get n log R by L. This is what we get. N log R by L. That is here. Now we integrate this tan theta. Tan theta, integral of tan theta log sec theta by 2. Log sec theta. So this becomes n log sec theta, okay? Minus, and sec theta integral becomes log sec theta plus tan theta. definition of, so log of sec theta plus tan theta. Fine, alright. I'll rub the first column, okay? This will rub it, okay? So now, if we insert the limits, how much will it be? N log R by L barabar. This N will go there. The log of secant theta by sec theta plus tan theta. Fine. N will go here. R by L power N log of secant theta by sec theta plus tan theta. R becomes R by, this becomes R by L power N. This basic both sides is just sec theta power N by sec theta plus tan theta. So this becomes R is equal to L sec theta by sec theta plus tan theta power 1 by N. This is the equation between R and theta. This is therefore the required polar equation of trajectory of the swimmer. Okay. This is therefore the required polar equation of trajectory of the swimmer. R is equal to L sec theta by sec theta plus tan theta power 1 by N. Alright. This was the 50th video on the relative velocity. I'll make one more video on relative velocity, that will be 59th, and that will be the end of this relative velocity chapter. Fine. After that, I'll draw a video on rigid body kinematics. Okay. There will be 4 chapters that will specify in the coming videos. Okay. I close it here. Fine.